Okay, I'm going to go through the SBAC pages 1 and 2 and just kind of show you the answers and show you where or how, kind of explain how I solved it. So number 1, which decimal number is equivalent to 5/8? The correct answer is B, and the way you do that is you just divide the numerator into the denominator, 5 divided by 8, and you get 0.625. Number 2, which fraction is equivalent to 0.45 repeating? Initially, I picked B because I didn't realize there was a repeating sign there, but there is. It's hard to see. So the correct answer with that is C. And the way you do that is you say X is equal to 0.45 repeating. So if X is equal to 0.45 and you multiply both sides by 100, you get 100 times X is equal to 45.45 repeating. When you subtract these two, you get 99X, and then the 0.45 repeating cancels out, and you're left with just 45 minus 0, which is 45, and then you divide by 99, X equals 45 over 99, and then that simplifies to X equals 5 over 11. Going down to number 3, which number is the closest estimate of the value of pi squared? So you know that pi is 3.14, and you know that 3 squared is 9, so it can't be 9 because that would be 3 squared and you're dealing with 3.14. If you square 3.14 times 3.14, you do get close to 9.9. So that's a good estimate. Jumping back up here to number 4. Which number line shows points plotted at square root of 7 and the square root of 23? So what you need to do is you need to figure out what are the two closest perfect squares to the square root of 7 and what are the two closest perfect squares to the square root of 23. So the square root of 7 is going to be between the square root of 4 and the square root of 9. So the answer is going to be between 2 and 3. So you're looking for a dot between 2 and 3, which is going to be any of these three. And the square root of 23 is between square root of 16 and square root of 25, so between 4 and 5. So the square root of 7 is, while it's between 2 and 3, it's kind of almost right in the middle. So it's going to be right, or it's a little bit more than halfway, so it's going to be right there. And then the square root of 23 is really close to 25, so you know the answer is going to be close to 5. So that means B is the correct answer. Number 5. Which point on the number line below is located closest to the square root of 18 over 2? So the square root of 18 is close to the square root of 16 and square root of 25. So you know the answer to what is the square root of 28 is 4 point something. So you want to put 4 point something over 2. And you know 4 divided by 2 is 2. So your answer is going to be 2 point something. So point A is the best because B is too far at 3, and the answer is definitely not over 4. You know the answer is 2 point something, and this is a little bit past 2, so that makes the perfect answer. Number 6. What is the value of the square root of 8 plus the square root of 2 to the nearest tenth? So a good answer to this question is you know that the square root of 8 and the square root of 2 are both irrational, and we know that irrational numbers are numbers that are never-ending, or imperfect squares are irrational, and decimals that go on forever but do not repeat are irrational. So you know that this answer together is going to make a decimal that does not repeat or end because it's irrational. That's explain why an exact value cannot be found because they're not perfect squares, they are irrational. Okay, let's see, going down. Page 3, I believe it's page 3, or page 2. Number 1, a yoga mat is 7/16 inches thick. What is this fraction expressed as a decimal? Actually, this could be page 1. I apologize, they must have scanned backwards. So above was page 2, and this is page 1. A yoga mat is 7/16 inches thick. What is this fraction expressed as a decimal? So what you're going to do is you're going to divide 16 divided by 7, but 16 times nothing is 7, so I added a 0, and I put a decimal up here. 16 goes into 70 4 times, that gives you 64. Subtract those, 16 goes into 63 times, that gives you 48. Subtract those, 16 goes into 127 times, that gives you 112, and then 16 goes into 85 times, so your answer is 0.4375. Number 2, look at this repeating decimal. If this number is written as a fraction in lowest terms, what is the numerator of the fraction? So you know that x equals 0.4166 repeating. What you want to do is you want to try to get rid of this repeating decimal. So if you multiply both by 1,000, you get 1,000x equals 416.666 repeating. However, if I were to subtract these two, I would still have a decimal, and that's what I want to get rid of. So I'm also going to multiply it by 100x on both sides. And then I get 100x equals 41.666 repeating. Now my 0.6 repeating is going to cancel. And I'm going to have 1000x minus 100x, which is 900x. 416 minus 41 is 375. X equals 375 divided by 900. And that's simplified. X equals 5 over 12. The question is asking what is the numerator of the fraction, which is 5. Number 3, look at this expression. Square root of 10 minus the square root of 3, which is the best estimate of the value of the expression. So you want to find the two closest perfect squares, which is the square root of 9 and the square root of 4. So you know your answer is going to be, so 10 is 3 point something, square root of 3 is 1 point something, but it can round up to 2. When you subtract 3 minus 2, you get 1. So therefore, you know that the closest estimate is going to be around 1. 0.16 is too low. 2.65 is too high. So it's got to be 1.4. Find point P. Point P represents an irrational number on this line. Which number can be represented by point P? So you kind of just do a little guess and check over here to see, on average, what these are. So you know pi is 3.14. 3.14 divided by 2 is approximately 1.57. Square root of 3, closest to the square root of 2, so it's just a little bit below, with the square root, a little bit below 2, square root of 4. Square root of pi divided by 3 is about 1.05, and then the square root of 2 is about 1.414, so which is the closest up here? For P, it's like right below, I think 1, 2, 3, 4. This is between 1.4, 1.5. This is between 1.5, 1.6. That answer is right there. Number 5. Which point best approximates the location of the square root of 11 on the number line? So it's between square root of 9 and square root of 16, between 3 and 4, but closer to 3. 11 is much closer to 9 than it is to 16. Therefore, A is the best choice. Number 6. Approximate the square root of 20 to the nearest tenth. Show or explain your work. So again, all we're doing here is we're constantly finding the closest perfect squares. So the square root of 20, closest perfect squares are the square root of 16 and the square root of 25. You know your answer is between 4 and 5. So then you just kind of do a little bit of guess and check. So I know 4.4 times 4.4 is 19.36. 4.5 times 4.5 is 20.25. So the square root of 20 is going to be right in between these two numbers, between 4.4 and 4.5, but it's much closer. It's only a quarter away from 4.5. So you can say the square root of 20 to the nearest tenth is approximately 4.5. All right, jumping over, I just want to make sure this is page. Okay, so it is going backwards, so I'm going to scroll up. So you can go down. This is page 3. Let's see. So the scatter plot shows the prices and quality ratings of 25 cell phones. Which best describes the relationship shown in the scatter plot? So the correct answer here is D. And we say D because there is a positive association. It is going up. The better the phone, the higher the quality. However, the points are not clustering in like a perfect, like over here, this is a strong positive because they're getting closer and closer to the line of best fit. These ones are much more scattered. So you have some phones that are $120 with a lower quality and some that are higher quality. So you want to say there's a weak positive association between the price and the quality. So D is your best answer. Number 2, the scatter plot shows the ages and heights of 20 pine trees. So what are the approximate coordinates of the outlier or outliers in the data? So an outlier is something that is a point that is kind of away from the rest of the line. So looking here, a little hard to read, but I noticed this point is off, so I want to kind of see where that's at. So it's about between 35 and 40, and it's right at 15, 38, 15. That's the only outlier I see. Everything else kind of falls within the line. Number 3, the scatter plot shows the distance and time needed for 30 college students to get to school in the morning. What is the best explanation for the 2 clusters of data points in the scatter plot? D is the best answer. Students who live close to school tend to bike to school, while students who live farther away tend to drive to school. So A says students who live close to school tend to take more time to get to school, which is very true, except A is not a good choice because they did not talk anything about over here. D talks about, while it doesn't say that people bike to school, but you can see that the closer they live to school, the longer it takes them to get to school. And then the farther away they live, the shorter amount of time. So you can assume they're biking or walking and then driving. Number 4, the scatter plot shows the distances and costs of 18 taxi rides. Which equation describes the best approximation to the line of best fit? So I wanted to look at the 2 closest points. I know that the y-intercept is 10, because if this line kept going, it's gonna go about to 10. Again, we're approximating, so it doesn't have to be exact. So I know one of my points is 0, 10, and then if this keeps going, 10 miles is going to be $50, so 10, 50. So when I do 50 minus 10 over 10 minus 0, I get 40 over 10, and my slope becomes 4. So my equation is y equals 4x plus 10. All right, I'm rolling back up. Oh no, it's upside down. Page 4 is upside down, so I'm gonna stop this right here and see if I can fix it.